So okay, we have calculated the moment uh, of resistance. M is equal to W into C1 square by 2. So how to calculate C1? C1 is equal to overhang plus length of connected leg to the base plate minus thickness of angle here. So now uh, next we have to calculate here, uh, consider, write down, consider unit width, consider unit width for design, for design for design bending moment, for design bending moment. So so the design bending moment, so the design bending moment at critical section, design bending moment at critical section is is so what is critical section? So this part is the critical section. So from the face of the gusset plate and face of the angle, so this distance C1 is the critical section. So for this critical section we have to calculate now design bending moment. So this is the actual bending moment. So design bending moment we have to calculate. So MD is equal to design bending moment. MD is equal to 1.2 into Fy divided by gamma m naught into ZE, into ZE. So now here ZE is the elastic section modulus, and here we have to calculate thickness. So here BD square by 6, ZE nothing but I by Y, ZE nothing but I by Y, and I by Y is nothing but moment of inertia about, this is BD square by BD cube by 12, and this is D by 2. So this 6 and this will be the square. So in this way here ZE, how to get ZE value? I by Y. So moment of inertia about x-axis is the BD cube upon 12 and y is the D by 2. So if we do this calculation, we will get this ZE value in this way. So here now, so as we have written here, consider unit width for the design of bending moment. What you are, please see here sentence, consider unit width for the design bending moment. So unit width for design bending moment, it means, now here D is nothing but depth, it means thickness of plate, and we have to use the unit width. So 1.2 into Fy divided by gamma m naught into B is the unit width, means 1, into D is the thickness, so T square divided by 6. So this is the your formula. Now we have written here, by equating bending moment at face of gusset plate due to intensity of pressure below the base plate to its moment of resistance. So this moment is the at face, only M we have calculated, this is the at face, and this MD is the moment of resistance. How much resistance will be the occur? So in this way we have calculated M and MD. Now we have to equate this M and MD. So now M is equal to MD. We have to M is equal to MD. So M is the omega into C1 square divided by 2 is equal to 1.2 into Fy divided by gamma m naught into 1 into T square divided by 6. And now here you can calculate now this thickness by using this formula. Thickness of the base plate you can calculate by using this, equating the moment to the moment of resistance. Are you getting? And this thickness should be greater than TF, thickness of flange. Thickness of flange. Okay, so now this is the step number 6. Now step number 7. So step number 7, again, assume 2 or 4 anchor bolts, 2 or 4 anchor bolts for holding down the base plate, holding down the base plate with dash dash mm diameter. That you have to use, how much diameter you have to use of this anchor bolt diameter, full stop. So this is the step number 7. We have to use 2 or 4 anchor bolts for holding down the base plate. This base plate we have to holding down with the concrete pedestal. Base plate we have to connect with the concrete pedestal. So we have to fix the concrete pedestal and base plate with the 2 or 4 anchor bolts. Okay, and now next step number 8. Step number 8, design of bolted connection. Okay, so how to design the bolted connection? We know better because we have designed the earlier bolted connection. So you can see, first we have to calculate in the bolted connection, design shear strength. We have to calculate. How to calculate that? A and B into FUV divided by under root of 3 gamma M1. Then small b, what we have to calculate? Design bearing strength. We have to calculate again bearing strength. Then bearing strength, how to calculate? 2.5 into kb into d into t into fu divided by gamma m1. And so minimum design strength. So design strength of bolt is equal to what? Minimum of shearing and bearing. So minimum of here small a and small b is the your design strength. And after the design strength, you have to calculate the number of bolts. here. So number of bolts is equal to, you have to take here now 50% load. 50% load will be transferred on the bolt and 50% on the directly gusset plate. So 50% load transferred by the connection. It means 50% लोड हा तुमचा कनेक्शन्स घेणार आहेत, म्हणजे बोल्टेड कनेक्शन, आणि उरलेला 50% लोड डायरेक्टली कॉलम गसेट प्लेट वरती ट्रान्सफर करेल, डिवाइडेड बाय युअर डिझाइन स्ट्रेंथ. So in this way you can calculate the number of bolts, and after calculation of number of bolts you have to draw the sketch. Again, if welded connection is there, if you have to design welded connection, if design of welded connection, if welded connection is there, then welded connection so in welded connection we have to calculate first size of weld. So how to calculate size of weld? Size of weld is depends upon the thickness of, now here you are using thickness of the gusset plate. Then after the size of weld you have to calculate throat thickness. So how to calculate throat thickness? 0.7 into S. After calculation of the throat thickness we have to calculate the strength of weld. So strength of weld is equal to, what is formula? LW into T into FU W divided by under root of 3 gamma MW. And so now here by equating 50% load on column, by equating 50% load on column and strength of weld. So 50% load of column is P by 2 is equal to LW into T into FU divided by under root of 3 gamma MW. So I am going fast because this part we have seen many times. So that's why I am writing fast. And so here we have to calculate this length of weld required for the weld. So design of bolted connection, it means we have to calculate number of bolts, and design of welded connection, it means we have to calculate length of welds, length of weld. That's it, simple. bolted connection डिझाइन करायचं म्हणजे नंबर ऑफ बोल्ट काढायचे, आणि वेल्डेड कनेक्शन डिझाइन करायचं म्हणजे लेंथ ऑफ वेल्ड काढायची. सो लेंथ ऑफ वेल्ड काढायची म्हणजे आपल्याला ही प्रोसिजर फॉलो करायला लागते. अगोदर साईज ऑफ वेल्ड माहित असावं लागतो, थ्रोट थिकनेस. मग साईज ऑफ वेल्ड कशावरून काढतो? तर थिकनेस ऑफ प्लेट ज्याला कनेक्ट करायची आहे, ज्याला वेल्डिंग करायचं आहे ती प्लेट किती थिकनेस आहे त्याच्यावरून साईज ऑफ वेल्ड. मग पेज नंबर 48 वरती जावं लागतं फॉर दॅट साईज ऑफ वेल्ड. देन थ्रोट थिकनेस. सो फॉर्म्युला फॉर थ्रोट थिकनेस इज 0.7 into S. साइज ऑफ वेल्ड मिळाली की थ्रोट थिकनेस मिळतो T. And again strength of weld. So strength of weld is equal to this formula. So if we equate strength of weld to the load, then we will get the length of weld. Simple is there. Are you getting? So in this way you can design the bolted and welded connection. And this LW is should be less than the available length. This length of weld should be available, should be less. Are you getting? This length of weld should be less than the available length. So this is the procedure of the your design of gusseted base. Okay, so now we will see the example on this gusseted base. Okay, so now example. So write down okay, write down a column ISHB 350 column ISHB 350 at 64.7 kg per meter carries an axial axial compressive factored load axial compressive factored load 1700 kilonewton 1700 kilonewton full stop. The column ISHB 350 at 64.7 kg per meter weight uh, carries an axial compressive factored load 1700 kilonewton full stop. Design bolted gusseted base with base plate with base plate on M20 grade concrete pedestal M20 grade concrete pedestal. Use 20 mm diameter bolt for connection full stop. Use Fy is equal to 250 Newton per mm square and Fe410 So this is the example and we have to design the gusseted base, bolted gusseted base, means we have to use here bolted connection. So now we will see the design procedure. Step by step we will follow the procedure. So step 1. Step 1, we have to calculate bearing strength. Calculate bearing strength of the concrete. Bearing strength of the concrete. So how to calculate? That is the 0.45 FCK. So FCK is nothing but grade of concrete is given. So how much grade of concrete? M20. So 0.45 into 20. So how much? It will be 9 Newton per mm square. The bearing strength of concrete is it will be the 9 Newton per mm square. So this is the step 1. Now follow step 2. Step 2, what is step 2? Calculate the area, calculate the area of base plate. So area of base plate AP is equal to factored load divided by bearing strength. Factored load divided by bearing strength. So factored load is 1700 into 10 raised to 3 divided by bearing strength is here 9. So how much area? Tell me. Area of plate is equal to factored load divided by bearing strength. So bearing strength. How much area? Tell me answer fast. One 88.88 into 10 raised to 3. 188.88 into 10 raised to 3 mm square. Okay. So now this is the area of the plate. Now we have to calculate we have to go step number 3. That step number 3 is we have to assume the some dimensions of the plate. So in step number 3, here we can write design of the gusset plate. Design of gusset plate. So here we have to assume first thickness of gusset plates. Thickness of gusset plate. So as what is the condition for thickness of gusset plate? So thickness of gusset plate should not be less than 16 mm. So here we will assume 16 mm thickness of plate. Are you getting? So it should not be less than 16. So here we can assume 18, 20, but here we have assumed now the 16 mm. So small b now. So we have to assume the gusset angle. So here we have to assume, so assume gusset angle. So that we have to take from the steel table. That gusset angle we have to take from the steel table. So gusset angle. So generally gusset angle, as I told you, the big depth or width of the section should be there. So here we will assume 150 by 115 by 15 mm. So I think 16 mm angle is not available. Our third condition is the gusset thickness of gusset angle and thickness of plate should be same. Thickness of angle, thickness of plate should be same. But if section is not available of 16 mm, I think 16 mm section is not available in the steel table. So here we can select from the 12 to 15. So here 15 mm we have selected. Okay, this is the clit angle we have selected now. So now this is the your step number 3. So now next step number 4. So step number 4 is the calculate size of base plate. Calculate size of base plate. So size of, while calculating the size of base plate, we have to calculate first length of plate. So how to calculate length of plate? So length of plate we can calculate by using this formula, that is depth of column plus 2 into thickness of gusset plate. Depth of column plus 2 into thickness of gusset plate plus 2 into 2 into 2 into length of connected leg, 2 into length of connected leg to base plate, 2 into length of connected leg to base plate plus overhang, plus overhang, plus overhang. So now see, so now length of plate we will calculate. So length of plate is equal to depth of column. How much? 350. 350 is the depth of column into 2 into thickness of gusset plate. So we have used the thickness of gusset plate 16 mm. So 2 into 16 plus 2 into length of connected leg. So length of connected leg to the base plate. So we will keep the, so this is the angle. So this depth we will place as a 150 and this will be the 115. So here 2 into 115. 2 into 115. And now overhang. So that overhang also we have to assume that overhang will be the 2 into 10 mm. So it means we will assume that this thickness, this angle, so this will be the 10 mm, this will be the 115 mm, this will be the 16 mm, this will be the 350 mm. So 350 plus 2 into 16 plus 2 into 115 plus 10. So in this way we can calculate the length of plate. So how much length of plate? Add this. How much? Okay, this will be the 622. I think 632 may be there. Yes, 632. 632 mm. Correct. 632 mm will be the length of plate. Are you getting? So this will be the you will get the length of plate by calculation. Now we have to calculate the width of plate. So width of plate is equal to what? Area of plate divided by length of plate. So area of plate is 188.88 into 10 raised to 3 divided by length of plate is 620. So how much width of plate? How much width of plate? Tell me answer first. Okay, 298.73. So 298.73. It means we have to use this 300 mm. So width of plate will be the 300 mm. So this is the your step number 4. Now step number 5. Calculate intensity of pressure. Intensity of pressure, that is W. So how to calculate intensity of pressure? P divided by area of plate provided. Area of plate provided. So P is 1700 into 10 raised to 3 and area of plate provided is 632 by 300. So tell me the intensity of pressure in Newton per mm square. Intensity of pressure in Newton per mm square. How much? 8.96. 8.96 Newton per mm square is the intensity of pressure.